Hello everyone, this is Poonam. Today, this is the seventh part of the chapter Electricity for class 10th, and our topic is the combination of resistances. We have two types of combinations. That means the resistances are combined in two forms, in two types. The first is the series combination and second is the parallel combination. This is the diagram to show the series combination. That means we have two resistances R1 and R2 and these are connected with each other by end-to-end combination. And this end-to-end combination is called series combination, which provides maximum resistance. Second is the parallel combination. Parallel combination diagram is this. That means the two resistances R1 and R2 are combined with each other in this form, and this parallel combination provides the minimum resistance. In case of the parallel combination, there will be same point for joining these two or three resistances. Now the first is the series combination. In this series combination, the combined resistance of any number of resistances connected in series is equal to the sum of the individual resistances. For the resultant resistance R is equal to R1 plus R2 plus R3 and so on. That means how many resistances are connected, the resultant is the sum total of all the resistances which are connected in the series combination. For the series combination, there are 2 points to keep in our mind. The first point is each resistance has a different potential difference across its ends. That means suppose this is the diagram, so this R1 and R2 they have different potential difference. Second, but the total voltage is equal to the voltage of the battery. Suppose the battery is of 12 volt and these are the two resistances. This first resistance is getting the 8 volts and the remaining 4 volts is for the resistance number 2. Second point is the same current flows through each resistance. Means the current will be same but the potential difference will be different. So the same ammeter is required to measure the value of the current, but different different voltmeters are required to measure the different potential difference across each resistance. Now there will be the derivation of this formula. That means the resultant resistance of the three resistors in series. How the three resistors are connected in the series. This will be the diagram. These are the three resistors R1, R2 and R3 which are connected with each other in series combination. For R1 we have V1 potential difference, for R2 V2 potential difference and for R3 V3 potential difference. But as we have done that the current will be the similar, so the current in all the resistors will be I, and there will be the battery of V volt connected across these three resistors. Now let the three resistances R1, R2 and R3 they are connected in series and their total potential difference is V and the current will be I. The total potential difference is the combination of these three V1, V2 and V3. So we have the first equation V is equal to V1 plus V2 plus V3. Now according to the Ohm's law, V is equal to IR. For R1 we have V1, for R2 we have V2 and for R3 we have V3. So V1 is equal to IR1, for V2 is equal to IR2 and for V3 is equal to IR3. These are the equation number 1, 2, 3, 4 and 5. Now by putting the values of V, V1, V2 and V3 in equation number 1. So in place of this V, we are using IR, V1 IR1, V2 IR2 and V3 IR3. So we get this type of equation. In this equation we have common thing, that is I. So this I will be common on both the sides, so we will cancel out this I and we get the resultant resistance R is equal to sum of the three resistors. In this derivation we are using the three resistors. Similarly, if it was given, it will be given that there are the two resistors, there are 4, 5, 6 and any number of resistors, then you can derive the formula like this. For example, we have some numericals on the basis of this topic. For example, if the four resistances each of value 1 ohm are connected in series, what will be the resultant resistance? So this is the diagram. R1, R2, R3, R4, all the four are connected in series. So we have the formula R is equal to R1 plus R2 plus R3 plus R4. 1 plus 1 plus 1 plus 4, that is the total resistance is 4 ohm. Now the second question is, a resistance of 6 ohm is connected in series with another resistance of 4 ohm. That means we have two resistors, 6 ohm and 4 ohm. They are connected in series. That means the total resistance will be equal to 6 plus 4, 10 ohm. A potential difference of 20 volt. That means a battery is used, that's value is 20 volts. Now we have to calculate the current through the circuit and potential difference across the 6 ohm resistance. That means the current through the circuit means through whole the circuit, but the potential difference across the 6 ohm resistor only. So this will be the diagram. 6 ohm resistance and 4 ohm resistance both are connected in the series, and this is the 20 volts battery. Now this R1 is 6 ohm, R2 is 4 ohm and the potential difference will be 20 ohm, 20 volts. So the resultant resistance will be equal to R1 plus R2, that means 6 plus 4, which is equal to 10 ohm. Now the current, according to Ohm's law, I is equal to V by R. We have the formula for Ohm's law that V is equal to IR. So I is equal to V upon R. So we have value of V is 20 and R is 10. So we get the value of I, that is 2 ampere. Now in the second part, we have to calculate the potential difference across the 6 ohm resistance. This is the 6 ohm resistance, so the potential difference is different across the 6 ohm resistance. We have R is 6 ohm. Potential difference, total potential difference is 20 ohm, but we have to calculate the V1 only. So we have I is equal to 2 ampere. We have calculated in the first part. According to Ohm's law, again V is equal to IR, but we are using R1 only because in the question it is given that only 6 ohm resistance. So V is equal to IR, I is 2, R is 6. So the potential difference across this R1 is 12 volt. Now we can also calculate the potential difference across the 4 ohm resistance. Total is 12 and it is having 12, total is 20, it is having 12. So 20 minus 12, it will be equal to 8 volts. We can also calculate it. V2 is equal to IR2, V is 2 and R2 is 4. So 4 plus 2 is equal to 8 volts. So this is all about the series combination. That means the resistances are connected in the series combination. In the next video, we will discuss about the parallel combination.